Hello and welcome to this presentation regarding how to achieve a window perimeter ceiling system which protects the benefits of high-performance windows and doors via the Ilbruck i3 system. My name is Steve Wild and I'm Technical Consultant for CPG UK, principally for the Ilbruck brand. First, a very brief overview of who we are today as Tremco CPG UK. In June 2020, the Tremco Ilbruck organisation in Europe rebranded to form CPG Europe, bringing together 5 brands, all part of RPM International and with a turnover in the financial year 2020 of €400 million. The brands are Tremco, Ilbruck, Nullifier, Driveit and Flowcrete. Under this new structure and within these 5 leading brands, we can provide solutions for a wide range of requirements on a typical construction project. The 5 brands provide solutions for ceiling, bonding and insulation, passive fire protection, flooring, roofing and waterproofing. Within each segment we have the products, personnel and service needed to satisfy requirements from floor to roof and the inside and outside of the building envelope and beyond. We will be focusing today on the left-hand column and the Ilbruck brands. We're members of several trade organisations and hold a significant number of BBA and Kiwa accreditations and product assessment, particularly by IFT and MPA in Germany. So back to windows. From a functional point of view, the installed window is affected on 3 levels: weather tightness externally, air tightness internally, and often overlooked, thermal and acoustic insulation between in the middle layer. The latter is important in addressing the avoidance of thermal bridging. Air leakage, where the current pass figure to building regs is 10 cubic metres per hour per metre squared, albeit increasingly many buildings have been designed to achieve around or even less than 5. Whilst the window itself is likely to be more than capable of performing, it is often the case that less thought is given to the actual installation, which, if inadequate, can severely compromise the benefits of the product. When all of the relevant factors are taken into account, the most effective method of sealing a window is with a 3-level system. This recognises the 3 locations and conditions involved and provides an external breathable weathertight seal, thermal and sound insulation to the area between the frame and reveal, and an internal airtight seal. It's also important to realise that this follows the principle of inside tighter than outside, which allows the natural pressure gradient to move air and moisture vapour to the outside of the construction and avoids condensation and potential mould damage. The factors of importance when installing or sealing a window are the loading on the window, uncontrolled air loss, thermal bridging and weather resistance. In considering the sealing of a window, the extent of loading on the frame and potential resultant damage to the perimeter seal needs to be appreciated. All frames need to have a gap to allow for thermal movements. Wind loading could be significant due to location, and also just opening and closing puts stress on the overall perimeter. Any damage on the perimeter seal can compromise weather sealing and airtightness. When considering airtightness, the concern is uncontrolled air leakage. This therefore ignores controlled ventilation via trickle vents. Typical areas where air leakage could occur are shown, illustrated further via thermal imaging. Typical brick and block construction here with a cavity closer. This presents an air leakage risk from the window to the closer and the closer to the blockwork interfaces. Whilst the window may be sealed to the closer, air leakage will occur between the closer and blockwork. A test program was undertaken to measure the air losses through a series of gap sizes over a 1 metre length joint. At a differential pressure of only 6 pascals, and for example with a 2 mm gap, the air loss was 15 cubic metres per hour, which is equivalent to 5.1 watts per metre Kelvin, which is a measure of linear thermal transmittance, and a loss of 130 grams per metre per hour of moisture vapour. Significant leakage therefore will occur through small gaps due to the convection losses and thermal bridging involved. The linear thermal transmittance figure is 100 times more than the value stated in the approved value in accredited construction details, which we'll return to later. The effect of small gaps through a wall can be seen here in that the U value of the wall increases, i.e. gets worse, by almost a factor of 5. Thermal bridging is a significant issue and potentially responsible for 30% of the total heat loss through a building's fabric. In this example, the window is positioned too far out in the opening and a thermal bridging path is indicated. Condensation and mould could occur on the internal finishes. In order to resolve this problem, quite basic steps are required, such as ensuring insulation is present not just in the cavity, but also the reveal and with a closed cavity. The frame is set back in the reveal by at least 30 millimeters across the cavity, and the perimeter gap around the frame is insulated, usually with a gun-applied, ideally elastic PU foam. Of course, weather resistance is the first thing considered when sealing a window, but there are various factors to consider and product options available. There's guidance available for sealing windows and doors. BS 8213-4 2016 is a code of practice for the survey and installation of windows and doors, and was revised with the inclusion of alternative perimeter seals via impregnated foam tapes. There are more recommendations for avoiding thermal bridging by the use of insulation. This document is normally used in domestic type installations rather than commercial. The GGF guide was also revised in 2016 and follows the general principles of BS 8213-4. NHBC, via their guidance document 6.9, show various solutions for window and curtain walling interfaces. Here is an NHBC approved detail for the sealing of a curtain walling to rain screen cladding detail. The various seals are indicated in red and comprise an internal airtight BCL membrane indicated as internal DPC-DPM, which will, depending on materials used, act as a further line of defence against moisture ingress, thermal insulation to prevent cold bridging, and a primary and secondary weather seal. The latter is provided by a membrane which should be breathable, and the former by either a silicone type wet seal or impregnated foam tape, which would also be vapor permeable. Accredited construction details, or ACDs, are widely used to design various parts of a building and utilise standard details which have known generic values such as for insulation and airtightness. ACDs can be used in organising SAP calculations on new build construction. Here is an example of an ACD for steel frame construction. In terms of maintaining satisfactory levels of airtightness regarding window installation, flexible sealant, highlighted here in red, is recommended as indicated in this typical detail. This isn't a particularly technical or potentially durable solution. On a positive note, however, reference is also made to a flexible membrane, highlighted in green, which provides a more robust and technical option. There's no mention of provision for insulation in the window perimeter joint. If adopting such a detail, either default or approved psi values can be used in the SAP calculation. ACDs are, however, not particularly robust and include reference to generic materials only. When replacing the calculation with appropriate specific products, the values can be improved further. Similarly, an ACD here for masonry construction, where the window interface is shown, but without any recommendations for flexible membranes, thermal insulation to the perimeter, or similarly robust sealing solutions. ECDs are issued by the Energy Saving Trust and enable the designer to improve on the performance which would result from using ACDs. Although the principle of using ECDs is undoubtedly of assistance to designers, the details are not in themselves very robust and don't specify any particular products other than mentioning mastic seals and double-sided tape. These references are very generic and open to interpretation and may result in inappropriate materials being used. Here is an example of a detail endorsed by LABC, but again, no mention of insulation around the window or an airtight membrane. Here is a calculated detail illustrating a PVCU window installed into a brick and block opening, including a 100 mm cavity with closer. With only a silicone external seal, typical of PVCU installations, the psi value is 0.073 watts per meter Kelvin, whereas if sealing with a three-level system, for example, a I3 system, the psi value would reduce significantly due to the insulation between the frame and the reveal to a figure of 0.031 watts per meter Kelvin. This is achieved by applying a combination of impregnated foam tape and PU canister foam within the perimeter joint. Similar improvements can be achieved by using an enhanced three-level seal, which is an impregnated foam which is installed across the full depth of the window frame and provides the three functional sealing levels in one application. The example shown is for the jamb only, and the head and sill details also have to be modelled in order to arrive at a Y value for the SAP calculation. Despite official guidance and various recommendations and installation accreditation proposals, the robustness of such standards and guidelines can be questioned. The key issue is that the quality of high-value products, specifically windows in this case, is likely to be compromised by inferior quality installation procedures in relation to the interface with the structure. Why specify increasingly high-value products and then compromise the perceived benefits by poor installation practices or techniques? Here we can see poor quality silicone applications where the durability and performance are likely to be of concern. In the perimeter joint on the right-hand side, if it was intended to seal this with silicone, it would be interesting to see the finished work, given the excessive joint width and inconsistent amount of PU foam, which would hamper the insertion of a backer rod to support the sealant application. So now we can discuss what we consider best practice for perimeter sealing by using a three-level system. An example of how a three-level system works by utilizing the Ilbrook i3 system with its BBA accreditation and 15-year warranty. The external seal here is provided by TP600, a comproband tape, the thermal insulation by PU foam FM330, and the internal air tightness by ME508 duo membrane. The range of product options which form the i3 system is seen here. You've got the external seals on the left-hand side, the intermediate the insulation layer down the center, and the internal air tightness options on the right-hand side. And now we can see how these products can be applied to a typical joinery network lignum window. We have the TP600 as the external weather seal, the ME508 as the air tightness membrane, and the FM330 PU foam in the center providing the thermal and acoustic insulation. The BFRC window energy rating scheme has been in place for a number of years now, and although initially covering an A to E range, is now extended to A++ with a minimum of C to meet building regs. Irrespective of the changes, the calculation of the energy performance of the window is made without consideration of how it is installed and sealed into the opening. This can easily result in a compromise of actual performance, due particularly to thermal bridging around the perimeter. If the sealing solution was included in the assessment, there would be a quantifiable justification for use of more robust sealing methods. It's therefore important to consider these points when marketing or installing high-performance windows. Promotion of better quality sealing methods is a great way of complementing a top quality window product and providing peace of mind for the client. Now we consider the product options for the three sealing levels discussed so far in a little bit more detail. Impregnated foam tapes are impregnated with materials such as resins, which improve their resistance to weather ingress. Although providing a high level of driving rain resistance, they are vapor permeable, allowing any trapped moisture to escape to the outside. Their wide joint size tolerance greatly assists in dealing with varying joint widths. TP600 has BBA accreditation in its own right and as part of the i3 system. Proven performance over 25 years provides confidence for the installer and the client. Here we can see various advantages which impregnated foam tapes have compared with conventional wet sealants like silicone. The product name for TP600 derives from its minimum resistance to driving rain of 600 pascals, which is equivalent to violent storm conditions as measured on the Beaufort scale of wind strength shown here. At the upper levels of compression, TP600 will achieve more than 1,000 pascals. Following installation, the tape will follow the contour of the joint, including in this case the mortar, and maintain a tight seal. Shown here on the left, sealing around a composite window, where the tape is located on the timber frame component, and on the right to a PVCU frame. Here on timber windows, where the tape forms an unobtrusive seal. Similarly, with even more undulating joints against stone, the tape will follow the contours and provide a shadow line without the problems of achieving an acceptable sight line when using wet sealant. TP600 is equally suitable when the frames are installed into check reveals. In this case, it's applied to the face of the frame rather than the edge. Depending on the installation detail, a membrane may be appropriate as the external weather seal, either instead of an impregnated tape or in addition to, acting as a secondary seal. In this case, ME501 would be appropriate, also BBA accredited. The perimeter gap around the frame is frequently the interface area which is given less consideration than for weather or air tightness. Avoiding thermal bridging is, however, a fundamental consideration, and the opportunity to maintain acoustic insulation to the envelope could also be essential. Linear thermal transmittance can be reduced by selecting appropriate materials with due regard for the sealing materials potentially installed on either side of the insulation. I guess we've all seen these kind of foam applications. Perhaps there's more material outside the joint than inside. In the application on the left, the correct amount of foam has been applied, adequately filling the joint and avoiding the need to trim off any excess. On the right-hand side, the foam is being applied to the sill and will also be applied behind the airtight membrane on the left-hand side of the window. FM330 provides all of the benefits appropriate to the insulation of the joint, with acoustic reduction up to 60 decibels, 50% movement accommodation, and air tightness in addition to the thermal benefits. And finally, the air tightness layer to the inside. Hillbrook intelligent membranes are air and vapor tight and available in various formats with self-adhesive strips or plain and bonded with proprietary adhesives. Intelligent membranes are so called due to their variable SD value, which means they are more vapor open when the ambient humidity is higher and more vapor closed in lower humidity conditions. ME501 is normally applied as an external weather seal, but can also be used internally where its higher strength may be desirable. When supplied as a plain membrane, it's bonded with SP525 adhesive. Note the limitations where an EPDM membrane would be more appropriate, such as at sill conditions or where standing water may be present. Alternatively, the VV version is supplied with a self-adhesive strip to the back and front of the membrane with slip liners to aid location. Similarly, the SV version has two self-adhesive strips to the edges, 44 and 91 millimeters wide. The normal airtight seal utilizes ME508, which has a very similar presentation to the ME501 VV, which we've just seen. ME508 is again an intelligent membrane with variable SD values. Here we see some applications of ME508. Additionally, on the picture on the left, we see in the middle the ME003, which is a vapor control layer, and ME317, which is a joint sealing tape, airtight tape. So having explained the principles of the I3 system and the benefits of sealing to 3 levels around the window, we finally show how this can be achieved with the use of a single product, TP654 ILMOD Trio 1050. Here we see TP654 applied to a lignum window, where it fills most of the perimeter gap and provides weather and air tightness and insulation. TP654 ILMOD Trio provides all of the benefits of the 3-layer sealing functions in one product, saving considerable installation time. The product is comprised of an open cell foam impregnated similar to TP600, including an airtight film with 2 layers of closed cell airtight foam at the edges which locate against the window and structure. The weather tightness is now 1050 pascals compared with the 600 pascals provided by TP600, and the active film provides a variable SD value which allows drying out of the joint. It's possible to seal a joint tolerance of 6 to 15 millimeters or 10 to 25 millimeters with one application. TP654 also provides high levels of thermal and sound insulation. An alternative 3-in-1 version of Trio is TP650. This is normally supplied at 66 millimeter wide for a typical 70 millimeter frame and is ideal for domestic window replacements. TP650 is seen being applied here to the perimeter of the frame prior to the window installation. Following installation, the tape provides the typical black shadow line around the window. In summary, for the lignum window, CPG can provide the 3-level sealing solutions via I3 by the use of 3 separate products or a single Trio alternative. I hope you found the presentation of interest and now invite any questions.